Hypothesis testing. In this session, we will discuss what is hypothesis testing, interpreting and selecting significance level, type 1 and type 2 errors, one tail and two tail test, hypothesis test for population mean, hypothesis test for population proposition, hypothesis test for population standard deviation. These are the session that we will discuss here. First, we will discuss what is hypothesis. A hypothesis is the statement or an assumption about interrelationships between the variables, or we can say it as a hypothesis is a tentative explanation for certain behaviors, phenomenon, or events that have occurred or will occur. Different authors, they have given different statements uh, or different definitions. Some of the definitions I am stating here, so it will give you the more clear picture. First is that hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variables to some dependent variables. Okay, then next definition is a hypothesis states that we are looking for what we are looking for, and it is a proportion which can be put to a test to determine its validity. That means what we are going to test. Okay, suppose just for example, there might be in a classroom there is a boys and girls. If we want to go to test whether there is any significant difference between the boys and girls based on any test, it might be intelligence test, IQ test, whatever. So okay, so first we will have to see what we are going to looking at, whether there is any significant difference or there is no significant difference, or it might be that boys are superior than the girls, or girls are inferior than the boys, whatever. So this way we can also discuss. Now here we are giving also another example. Student who receive counseling will show a greater increase in creativity than students not receiving counseling. Next slides, what are the characteristics of the hypothesis? It gives clear and precise. Clear means what we actually want to do, and precise means actually we are getting that. Capable of being tested. That means the hypothesis is going to be tested. Stated relationship between variables. What is the relationship between the two variables? Dependent, independent, whatever. So limited in scope and must be specific. It should be very brief and it should be very specific, and stated as far as possible in most simple terms so that the same is easily understood by all concerned. So it should be in simple language so everybody can understand what exactly the hypothesis or what are the hypothesis that has been assumed for the present study. But one must remember that simplicity of hypothesis has nothing to do with its significance. Simplicity of hypothesis, that means it is very simple but it is not giving any clarity, or there might be the ambiguity. In that case it has nothing to do. Consistent with most known facts. Known facts means what are the things we are going to prove, that study might be supported by other studies, whatever. So responsive to testing with a reasonable time. That means there is a prescribed time, it might be 3 months, 6 months, whatever. So one cannot spend a lifetime collection data for test it should not be more than that. Explain what is claims to what claims to explain. That means it gives clarity what is that. It should have empirical reference. Empirical reference means it should have empirical reference. That means it should be supported with other researcher. That means who has done research in that particular area, whether it is supporting or not supporting. Then basic concepts concerning testing of hypothesis. Basic concepts, before knowing that we will have to know what is the null hypothesis and alternative hypothesis. In this context of statistical analysis, we often talk about the null hypothesis and alternative hypothesis. If we are to compare method A with method B, its superiority, or if we proceed on the assumption that both methods are equally good, then this assumption is termed as a null hypothesis. That means there is no difference between the two groups, whether A and B. As against this, we may think that the method A is superior or the method A is inferior. We are then starting what is the termed as alternative hypothesis. Then null hypothesis is generally symbolized as H0 and the alternative hypothesis is termed as HA. Suppose we want to test the hypothesis that the population mean B is equal to the hypothesis mean MH0 to DI 100. Then we would say that the null hypothesis is the population mean is equal to the hypothesis mean 100, and similarly we can express as H0 mu equal to a mu H0 equal to 100. If our sample result do not support this null hypothesis, we should conclude that something else is true. What we conclude rejecting the null hypothesis is known as alternative hypothesis. In other words, the set of alternatives to null hypothesis is referred to as the alternative hypothesis. If we accept H0, then we are rejecting HA, and if we reject HO, then we are accepting the HA. For H0 equal to mu H0 equal to 100. We may consider three possible alternative hypotheses as follows. Alternative hypothesis, this is the null hypothesis. That means the alternative hypothesis is the population mean is not equal to 100. That means it may be more or less. Then this is also HA and HO. The alternative hypothesis is that population mean is greater than 100. Then if we go this H0 less than H0, that means the alternative hypothesis is that the population mean is less than 100. The null hypothesis and the alternative hypothesis are chosen before the sample is drawn. The researcher must avoid the error of deriving hypothesis from the data that he collects and then testing the hypothesis from the same data. Alternative hypothesis is usually the one which one wishes to prove, and the null hypothesis is the one which one wishes to disapprove. Thus, a null hypothesis represents the hypothesis we are trying to reject. An alternative hypothesis represents all other possibilities. Now we will have to know what is the reason for rejection. If the rejection of a certain hypothesis when it is actually true involves great risk, it is taken as null hypothesis, because then the probability of rejecting it when it is true is the level of significance which is chosen very small. In the case of null hypothesis, should always be a specific hypothesis, that is, it should not state about or approximately a certain value. Generally, in hypothesis testing, we proceed on the basis of null hypothesis, keeping the alternative hypothesis in view. Why so? The answer is that on the assumption that null hypothesis is true, one can assign the probabilities to different possible sample results, but this cannot be done if we proceed with the alternative hypothesis. Hence, the use of null hypothesis, at times also known as statistical hypothesis, is quite frequent. The level of significance. It is a very important concept in the context of hypothesis testing. One should know it very carefully, because most of the researchers, they do mistake to find out at which level it is significant or not significant. That the thing. It is always some percentage, usually 5%, which should be chosen with great care, though thought and reason. In case we take the significance level at 5%, then this implies that H0 will be rejected when the sampling result, that is observed evidence, has a less than 0.05 probability of occurring if HO is true. In other words, the 5% level of significance means that the researcher is willing to take as much as a 5% risk of rejecting the null hypothesis when it is H0 happens to be true. Thus, the significance level is the maximum value of the probability of rejecting H0 when it is true, and it usually determined in advance before testing the hypothesis. Decision rule or test of hypothesis. Given a hypothesis H0 and an alternative hypothesis HA, we make a rule which is known as decision rule, according to which we accept H0, that means reject HA, or reject H0, that means accept HA. For instance, if H0 is that a certain lot is good, there are very few defective items in it, against is A, that the lot is not good, there are too many defective items in it. Then we must decide the number of items to be tested and the criterion for accepting or rejecting the hypothesis. We might test 10 items in the lot and plan our decision saying that if there are none or only one defective item among the 10, we will accept H0, otherwise we will reject H0 or accept HA. This sort of basis is known as decision rules. We have to know also what are the in hypothesis, what is type 1 error and type 2 error. In the context of testing of hypothesis, there are basically two types of errors we can make. We may reject H0 when H0 is true. We may accept H0 when in fact H0 is not true. The former is known as type 1 error and the latter as type 2 error. In other words, type 1 error means rejection of hypothesis which should have been accepted, and type 2 error means accepting the hypothesis which should have been rejected. Type 1 error is denoted by alpha, known as error, also called the level of significance of test, and type 2 error is denoted by beta, known as beta error. In a tabular form, this set 2 error can be presented as follows. In this case, H0 true, but if we accept, that means we are taking the correct decision. In case if we reject, that means type 1 error, alpha error is taking place. In the case of alternative hypothesis, a null hypothesis, suppose if it is false, anyhow we are we are rejecting, then we are taking it correct decision. Correct decision. The probability of type 1 error is usually determined in advance and is understood as the level of significance of testing the hypothesis. In type 1 error is fixed at 5%. It means that there are about 5 chances in 100 that will reject H0 when H0 is true. We can control type 1 error just by fixing it at a lower level. For instance, if we fixed it at 1%, we will say that the maximum probability of committing type 1 error would only be 0.01. Two-tailed test and one-tailed test. In the context of hypothesis testing, these two terms are quite important and must be clearly understood. A two-tailed test rejects the null hypothesis if, say, the sample mean is significantly higher or lower than the hypothesized value of the mean of the population. Such a test is appropriate when the null hypothesis is some specified value and the alternative hypothesis is a value not equal to the specified value of the null hypothesis. symbolically, the two-tailed test is appropriate. As in the case of two-tailed test, it is appropriate when we have H0 equal to H0 or H A equal to H0, which may means a null hypothesis. Zero. Thus, in a two-tailed test, there are two rejection regions, one on each tail of the curve, which can be illustrated as under. Here we can say that this is the unit, this is the unit, this is the normal distribution curve. Here, this is the H0 and this is the Z minus 1.96, and if it is a two-tailed test, so it should be both two sides. This is the side from here to here, and here is also the here, and the value should be 0.025. Here value should be 0.025, and this is the rejection region. This is also the rejection region. This is also acceptance regions. And acceptance and rejection regions in case of a two-tailed test that has been shown at 0.5 level. Both taken together equals to 0.95 or 95% of area. But there are situations when only one-tailed test is considered appropriate. A one-tailed test would be used when we are two tests, say whether the population mean is either lower than or higher than hypothesis value. For instance, if our H0 is equal to H0 or HA is less than H0, then we are interested in what is known as left tail test, wherein there is one rejection region only on the left tail, which can be illustrated as below. Suppose you just see if it is a one tail test, that means we are taking from left side and it is 0.05 0.05% level. This is also the rejection level. This is also acceptance and rejection regions in case of one tail test with 5% significant. This is also acceptance region, and here is also the Z equal to minus 0.165. This is H0. Rejection H0 is the sample mean of X false. So this is also the 0.50 of the area, and this is also 0.450 because we are getting 0.05 level on the left tail. That's why. Then in case our H0 equal to H0 or HA is higher than H0, we are then interested in what is known as one tail test, right tail, and the rejection region on the right tail of the curve as shown below. This is also earlier we have shown also on the left. Now this is also in the case of the right. So similar here is also the Z equal to minus 1.645. This is also both taken from equal 0.95 and our 95% of area, and this is the normal distribution curve. This is the mean median mode, or it is a H0, whatever you say. Acceptance of H0 if sample mean falls in this region. Now two-tailed test, except in the case of the two-tailed test, 5% significance level, acceptance and rejection regions in case of a two-tailed test, then what we should do? H0 equal to mu 0 or HA equal to mu 0, whether it is equal to or whether it is not equal to. If it is two-tailed test, then and in the case of the 0.05 level, then what it should be done? We can think in the left side it should be 0.025, and in the right side it should be also 0.025, and 0.025 and 0.25 it is becoming 0.05. So both two say, since it is a two-tailed test, so it is showing based on the normal distribution curves and on the both two sides. Now procedure for hypothesis testing. State the null hypothesis HO by H0 and alternative HA hypothesis. First, we'll have to see state a significance level, whether it is significant 1% level, it is 5% level, whether 10% level, etc. Then decide a test statistics. What are the tests should be used? It might be Z test, it might be T test, it might be F test, whatever. So based on that, we'll have to see how do we can go to test statistically. In case, suppose you just see after calculation this value, in the case of two groups, just for example, in a classroom there are 50 students, 25 boys and 25 girls. If we want to measure the personality test, we have used personality test. After that, we want to see what is the significant difference between these two. If we take the null hypothesis as a, there is no significant difference between the boys and girls in the classroom. An alternative hypothesis is that there is a significant difference between the two groups, or boys are superior than the girls, and girls are also inferior to boys. Okay, so after calculating this value, what are the values we are getting? After that, we will have to see the table. That is, that we can say the Fisher's table. From there, we will have to see this calculated value is higher than the table value, or this calculated value is lower than the table value. If the calculated value is higher than the table value, whether it is 0.101 level, 0.05 level, or whatever, so then we can say that there is a significant difference. If we find that there is no, find that the calculated value is lower than the table value, then we will say, no, there is no significant difference. That means what it will happen, then it should be treated as a null hypothesis. When we will get significant difference, then it will be treated as a alternative hypothesis. Okay. Then calculate the value at the test statistics that I told. Achha. Then calculate the p-value at given significance level from the table. That means we will have to see whether it is significant 0.05 level, 0.01 level, 0.001 level, whatever. So that we will have to see based on the value. Then compare the p-value with calculated value that I have already explained. Then p-value is greater than calculated value. That we'll have to see. Then we are accepting the null hypothesis. And in case p-value is less than calculated value, that means we are rejecting the null hypothesis. So in this way, we can go to test the hypothesis. Then limitation of the test of the hypothesis. Testing of hypothesis is not decision making itself, but help to decision making. Help for decision making. That is true. It's not a decision itself, but it helps. Test does not explain the reason as why the difference exists, but it only indicates that the difference is due to fluctuations of sampling or because of the other regions, but the tests do not tell about the region causing the differences. Tests are based on the probabilities and as such cannot be expressed with full certainty. Statistical inferences based on the significance test cannot be said to be entirely correct evidences concerning the truth of the hypothesis. So these are the presentation today. Thank you all. I hope all of you have enjoyed the PPTs, and if you have any question now you can ask to me and accordingly I can answer.